Okay, welcome to section 7.4. In this section, we're going to continue looking at probability. We're just going to take a look at some slightly more complicated rules. We're going to take a look at the union rule, the complement rule. We'll discuss odds and then some more properties of probability. Okay? All right, first off, the union rule. A union rule says that if you have two events, E and F, and they both are generated from that same sample space S, then the probability that E or F will occur is this formula right here. And it reads that the probability of E union F, so that's this left-hand side over here, is equal to the probability of E alone plus the probability of F alone minus the probability of the intersection of E and F. And so basically what this is going back to is this is going back to or connecting to that idea of if this is E and this is F, then the union would be all of that, all three of those regions, if you want to call them regions, of that Venn diagram. And so when we add E, we're adding these two pieces right here. When we add F, we're adding those two pieces right there, but effectively we added the middle twice, so we have to fix that. And that's why it's subtracted back off over there on that right-hand side. Okay. All right, so let's take a look at what this would look like in a scenario. Okay, so suppose two fair dice are rolled, one green and one red. Find the probability that the green die shows a 2 or the sum of those two dice is a 6. Okay, so my sample space is going to be 1, 1, 1, 2, 1, 3, all the way out to 6, 6. It's going to be all those different ways that those dice can land. 36 ways, actually. My event E is going to be green die 2. And if I'm going to make the following argument, that the first die is the green die, and the second die is the red die, then green die 2 would be the set 2, 1, 2, 2, 2, 3, all the way out to 2, 6, and that the number of elements in there is going to be 6. Right. Now, F is going to be our other event. F is going to be that the sum of the two dice is a 6. Okay. So that's going to be the set. Let's see. A 6 is a 1 and a 5, or a 2 and a 4, or a 3 and a 3, or a 4 and a 2, or a 5 and a 1. And then, what does E intersection F looks like? And I need that for over here. Well, that's going to be green 2 and sum 6. Well, if you think back to the way we defined this, the first die is the 2, so it's only that one. It's going to be the die pairing 2, 4. So then the probability of E union F is going to be the probability of E, which was 6 ways out of 36, plus the probability of F, and there are 1, 2, 3, 4, 5 in there, minus the probability of the intersection, which is that 1 way out of 36. Okay? So this number right here came from that sample space. This number right here came from this. I'm sorry, I said sample space, I meant event. And this number right here came from that event. Now let's actually do that math. 6 36 plus 5 36 minus 1 36 will give me 10 36, which reduces down to 5/18. Then, of course, I could turn that into a decimal if I needed to, but I'm just going to leave it at 5/18. Okay. That's the union rule. The complement rule, and we talked a little bit about this already, says that for any two events, E and its complement, the sum must be 1, so that the probability of E plus the probability of E complement must add up to 1. Most of the time, though, we don't use it in this form. We use it in either this form or this form. And both of those forms basically say the same thing. They've just taken that algebra here and either solved it for the E or solved it for the E complement. Okay? All right, so let's take a look at what we're saying here. Let's take a look at a complement rule problem. So suppose a fair die is rolled. That means that my sample space is 1, 2, 3, 4, 5, and 6. We're supposed to find the probability that any number other than 5 is rolled. So my job is to find the probability of not a 5. Well, I'm going to use the complement rule and say that that's just 1 minus the probability of rolling a 5. So that's going to be 1 minus 1/6, and 1 minus 1/6 is 5/6. Now for this example right here, you might be looking at it and saying, hey, that's such a simple experiment, so few things in the sample space. I don't know if I really need anything fancy to solve that. I don't need this fancy math over here to solve this. You're most likely right. For this problem, the complement rule is kind of overkill. But the complement rule at its core is nice because when things are difficult, it's easy to use. So for example, let's change this from a fair die to 2 fair dice. So now we've got the sample space that's 1, 1, 1, 2, 1, 3, all the way out to 6, 6. And suppose we want to find out the probability that the sum is not 3. Well, the probability that the sum of the two dice is not 3 is going to be 1 minus the probability the sum of the dice is 3. So that's going to be 1 minus 2 out of 36. Now, if you're wondering where that 2 out of 36 came from, there are only 2 ways in that sample space to roll a 3. You can only roll a 3, and I'll call that E just to make it simple, if you roll a 1, 2, or if you roll a 2, 1. That's the only way to get the sum to be a 3. So 1 minus 236 would give me 34, 36, and then I could reduce that down and call that 17/18 if I wanted. And so when sample spaces get bigger like that, and events and complements get more difficult to calculate, sometimes it's easier to go the complement route than it is to go the event route. Okay. Oh, hey, what do you know? Here's another example that's much better. Okay, so we're back to the 2 fair dice. So we'll still have that sample space of 1, 1, 1, 2, 1, 3, all the way out to 6, 6. And the number of elements in that sample space is still 36. I'm supposed to find the probability the sum is greater than 3. So the probability that the sum is greater than 3, that means the sum is a 4 or a 5 or a 6 or a 7 or an 8 or a 9 or a 10 or an 11 or a 12. I don't want to do that. So I'm going to use the complement rule and say that the sum greater than 3 is 1 minus the probability that the sum is 2 or 3. 3 or less, but 2 or 3 is just 3 or less. Okay? And so that's going to be 1 minus 3 out of 36. Again, if you're wondering where did that 3 come from? Well, over here in that sample space, 1, 1, 1, 2, and 2, 1 are the only ways to roll 2 dice and get a sum of a 2 or a 3. So that's going to give me 33, 36, which is 11/12 when it's reduced. And there's my probability. Okay. Odds are a whole different thing, and what I'm going to do is I'm going to stop this video and come back and then talk about odds in the second video.